everybody. Today we're going to be studying the natural logarithm. And before we can study the natural logarithm, there is a special number that we have to know about. That number is denoted as e, okay, for a natural number. Okay, we call it e, but e is just a number. And now, how do we figure out what e is? This is kind of like when you guys have pi. And we know, pi we know is 3.1415. Well, there is another special number. It's called e. Okay, and this number is a natural number. We call it the natural number in mathematics. And we also have the natural logarithm. Now, the natural logarithm is a logarithm with this special number e. But instead of putting log of base e, we say the natural log. Okay. Now, what is this whole number? Okay. The number is an infinite number that we get as n approaches infinity. So I could tell you that, as this gets bigger, we get a better result or a more accurate result for the number. So for example, I could put 1 plus 1 over 1000 do that 1000. Okay, and this right here is going to give me an approximation of the number. Okay, now this, I can make that n bigger. And that's going to give me a much better approximation of the natural number. Now this number appears to appear in the real world. That's why we call it the natural log. And then we could even get even more precise calculation. And that will give us another, it will give us the same number, but with more numbers. Okay, so the number, let me give it to you. The special number e is equal to 2.71828. Okay, that is the number. Okay, there's nothing magical about that number except that it does seem to appear in many applications, and it seems to appear in the natural world as well. Okay, in this video I can't really explain too much what that is or but something that you should know about. All right, so let's keep going. Now let's talk about the natural logarithm. It's a normal logarithm, but it has base e. So once again, instead of writing it like this, logarithm base e, we actually write it like this, the natural log. And this right here, we already assume that the base is e. Now, if I give you log like that, we assume that that is already the log of base 10. So on this one, we already assume that the logarithm is e. All right, so for this first example, it says write in exponential form. So we have the natural log of x is equal to 5. Well, let's go back to our definition that we had before. Our definition that we had before was natural log of b n is equal to k. Okay, and we knew that if we write that in exponential, that would look like this. B to the k is equal to n. Well, how about for the natural log? For the natural log, we already know that the base is e. So we don't really have to write it. So if I have natural log of n is equal to k, then the answer is going to be e to the k is equal to n. Okay? All right, so how do we rewrite this again. So it would be e. Okay, what is the k in this case? The k is 5. So e to the 5th is equal to x, which is n in this case. Okay, and that is how we write it in exponential form, just like how we write it before. It's just a little bit different. So you could say, well, the definition for natural log is going to be natural log of n is equal to k, and that is the same as e to the k to the n. So here's my definition. It's technically the same definition that we had before. It's just that this time the base is always e. All right, so we're gonna write, we need to write this in natural log form. So, you know, we write ln for natural log. The n in this case, okay, it's 7. So we're gonna write L of 7 is equal to, and the exponent is right there, that's the k. So that's the natural log. And in your calculator, you are gonna see the natural log in there. As you can see in there, we do have a ln in there. So it's always helpful to know to have it in there. So we have log, that's base of 10. So if I find, let me tell you, if I find the log of 10, I get 1. Okay, because 10 to the first, you know, the exponent is 1, so we get 1. If you find the natural log of e, which is 2 points, you can see the number there, the natural log of that will also be 1. Okay, so you can see even in our calculator that natural log uses base e, logarithm, or that log, uses base 10. All right, let's do this one here. It says find the value of that, and then this right here. Once again, guys, this might seem confusing, but it's not really. If you want, you can rewrite this using our definition that I gave you there. And you can say, instead of question mark, let's write an x. And then if we figured out what the x is, then we found the natural log. So use the definition there. This will be, this right here will be my n. And this right here will be your k. So then we have e to the x is equal to e to the 5th. As you can see, x must equal 5. So in reality, this is just 5. And the reason why this happens is because you just get the exponent right there. Because, remember, the base is e, so that answer is going to be there. So that's going to be your answer. This is also inverse of each other's. So what you're going to get in this one is, if we translate this using our definition, okay, this right here will be your, what we call our k, and this right here will be your n. And let's try to figure out what x is. So the n will have natural log of x is equal to, well, the k is natural log of 7. As you can see, we have x is equal to 7. So this right here will also be 7. So you can see there that those are inverses of each other. All right, let's keep going. Simplify this guy right here. We have natural log of 1 over e to the 2nd. I already know, guys, that the base of this is e, okay? Now let's rewrite this as e to the negative 2. Guess what the answer is going to be? Since the base is e, your answer is just right there. And that is all. That's really all you're gonna find. Now, what if I tell you, hey, you know what? I did not get that. Let's do it a different way. Let's say that this right here is x, and we're trying to figure out what x is. If I use my definition, oops, let's erase that. Sometimes this thing is acting weird. Remember, the definition is ln, n is equal to k, and that is equal to e to the k is equal to n. Okay, you can translate it from one to another, and you will get e, okay, to this will be the n right there, and this will be the k. Okay, so it will be e to the x is equal to 1 over e to the second. Well, bring the e to the second on top, and then you get e to the negative 2. You can see that x is equal to negative 2. So that's what you get there, negative 2. But then all you have to do is just realize that the exponent is the answer. All right, we're gonna be solving those. We can do that by simply translating from logarithm form into exponential form. Once again, the formula is going to be natural log of n is equal to k. And then that will be equivalent to e to the k is equal to n. So in this one, we can translate this right here will be your n, this right here will be your k. So it will be e to the k, which is 2, and then n in this case is x, and then that's it, guys. That you've solved it. That's x. X is equal to e to the second. That's it. Okay, there's no mystery there. It's just e to the second. We never change this to a decimal. Never. Because we want to keep it as an e. Okay? It's like if I give you an imaginary number, we write it always as an imaginary number. We never write it like this. Okay? Or we usually don't write pi as 3.1415. We usually just leave it like pi. Well, it's the same thing with the natural number. All right, let's do this one here. Once again, this right here will be your n, and this right here will be your k. So then we have e, the k is 2, and then 1 over x is that. What you could do on this one is multiply both sides times x, and then you get x e to the second is equal to 1. And then just to finalize it, x is equal to 1 over e to the second. Okay, and that will be your answer for that one there. All right, let's do a couple more examples and then we'll be done. Let's go ahead and solve this one. E to the 2x is equal to 9. Okay, we might use a calculator, I don't think so, but let's do this one here. Since we are dealing with, so there's two ways we can do this from. One way is by translating it, and the other way is by taking the natural log on both sides. Both answers are equivalent the same. Okay, so I'll do it both ways. I'll do it method 1 and method 2. Method 1, it says, well, the natural log of n is equal to k. Then I have e to the k is equal to n. Method number 1 is by using the definition. So I'll use the definition here, and I'll have to translate from that to that right there. So we'll have to be the natural log Okay, n, what is n in this case? The n is 9, and this right here is your k. So the natural log of 9, okay, is equal to 2x. That means that x is going to equal the natural log of 9 divided by 2. Now, could you actually find a decimal answer? Yes, you can. If you go to a calculator, we can give you a decimal answer, although if you were to give me the other one, I would be totally okay with that. So you have to write the 9 first, and then write natural log. The natural log of 9 is 2.19. Then you want to divide that by 2. Then that gives you your final answer, which is 1.09. Let's just round that up to 1.110. All right, the second way you can do this, which is actually my favorite way because I don't have to remember the definition whatsoever, is like this. And I think this is a fun way to do it. We're gonna actually do the natural log on both sides. You're gonna see that you're gonna get the same answer. What happens in here? Well, this right here, you bring it right there, and then you get 2x is equal to the natural log of e. And now, what is the natural log of e? The natural log of e, since the 1 is an exponent right there, then that's what you get there. This right here is 1. So the natural log of e is just 1. So honestly, we just get 2x is equal to the natural log of 9, which is pretty much that right there. And then you get x is equal to the natural log of 9 divided by 2, which is that right there. And then if you want, you can find the decimal of that as well. So two different ways of doing the problem, but you get the same answer. Okay, so that's that there. Let's see if we can write each equation in exponential form. Okay, so let's go ahead and do that. For that, we need our definition. Our definition is, once again, we have natural log of n is equal to k, and that is congruent to e to the k is equal to n. So let's rewrite that as e. Our k in this case is right there. Negative 1.10 is equal to n, which in this case is 1 over 3. And honestly, guys, that's all we have to do because they're asking us to write the equation in exponential form. And that is technically all we have to do. Okay? So that is that one there. Make sure you have written that down. Let's go ahead and go to the next one. So write each equation in logarithm form. Once again, guys, we have our definition, natural log of n is equal to k. And then we have e to the k is equal to n. So on this one, we're going from that to that there. So we're going to write natural log. Okay, what is the k in this case? The k is right there. Okay, and this right here is my n. Okay, so natural log of 1.65 is equal to, okay, half. By the way, I don't know if this is accurate, but we're just rewriting it. But I'm not 100% if that's actually accurate. It doesn't seem like it. All right, let's do this one here. Simplify the natural log of 1. Here's what you have to realize for that first one there. A natural log of 1 is the same as e to the 0, because anything to the 0 power is always 1. It's like 3 to the 0. It's actually 1. 4 to the 0, 5 to the 0. Any number to the 0 power is always 1. Okay? So in this case, the natural log of e to the 0, since the base is e and this is e, then we just get what's in there. And we get 0. And remember, guys, log of 1 to any base is always 0. Okay? If we put a 1 in there, it's always going to be 0, no matter what it is. This one here, I could tell you that the answer is going to be 5 already, because those cancel each other. But if you want to see it a little bit better, you can set that equal to x, and then we can translate it. It will look like this. So it will be natural log of x is equal to the natural log of 5. And then we can see that the x is equal to 5. Okay? So that's a way you can think about that problem. How about the natural log of 0? How could I get 0 in here? Okay. Well, we can try to solve this. We could say, let that equal to x, and let's translate it. We will have e, okay, to the x is equal to 0. Could I ever get 0 though? Okay, is that even defined? Well, let's try to see. Is there one where I could actually get 0? If I try to take the natural log of 0, so if I put 0, oops. Uh-oh. All right. If I try to find the natural log of 0, so I'm going to press 0 and try to find the natural log, it's going to say that it's an invalid input. And the reason for that is because we cannot find no x or no exponent in such a way that will give you 0. So natural log of 0 is actually undefined. We cannot find that. So we say that that's undefined. Okay? Let's keep going. We're going to write this as a single logarithm. So everything that we use for logarithm applies to the natural log. It's the same thing. Okay, so we're going to be using some of those rules that we learned previously. Okay. One of the rules allows you to actually put this 1 over 3 right there. So we have natural log of a to the 1 over 3 plus natural log of 5 plus, okay, so this is a tricky one. We have 3, technically this is the same as 3 times 1. I could rewrite this as the natural log of e, because the natural log of e, remember there's a 1 right there, so this right here is 1. So I'm going to put this 3 right there, so it's going to be natural log of e to the 3rd. Okay? Now I'm going to use my rules. One of the rules said that, well, first of all, a to the 1/3, that's the same as the cube root of 8. Okay, the cube root of 8 is actually 2. And then this rule right here, there is a rule that says that I could actually multiply this 2 and this 5 right there. We have natural log of 2 times 5. Remember, we have to go back to the same rules that we learned before. Logarithm rules. So 2 times 5 is going to be 10 plus logarithm of e to the third. Then same rule applies here. Our final rule is going to be logarithm of e to the third times 10. Or actually, I'm going to write it like this. Logarithm of 10 e to the third. Which I'm going to rewrite like that. I'm going to write like that. Okay? And that's how you do that one. It's a little bit more complicated. There's a couple things that I did in there that are a little challenging, but I think hopefully everybody got it. Remember those rules that we have to know. I'm not going to write them down. Just go ahead and look back at your notes if you don't remember the rules, okay? Alright, finally we're gonna solve for x on this one here. We're gonna use different strategies. So on this one here, I could translate this to look like this: e to the 9. This is my k. This is my n. E to the 9 is equal to x squared. Take the square root on both sides. We get square root of e to the 9 is equal to x, and that will be my final answer. Okay. Let's translate this one as well. We have e to the negative 1 is equal to x minus 4. And that means that the answer is going to be x is equal to 4 plus e to the negative 1. If you want, you can rewrite it like this: 4 plus 1 over e as well. Let's do C. For C, what I could do is we can use a definition once again. The definition is natural log of 2 is equal to x minus 2. And then x is equal to 2 plus the natural log of 2. You could use a calculator on this one. Press 2 and then natural log. Okay, and then you can add the 2 there. And that will give you 2.69. Okay, let's do D. Once again, we can use our definition. Natural log of 25 is equal to 2x. That means that x is equal to the natural log of 25 over 2. We can use a calculator to finalize this problem. We put 25 natural log divided by 2 gives you 1.6 on, let's do 1.61. Okay, and that's how we solve a couple of those problems in there. Alright guys, that is all for this video. Hopefully you guys learn about the natural log. But yeah, I'll see you guys in the next video.